Are you hot yet?
Just cooling down. The rain just cools down 20 degrees. So
Let me tell
we're
you,
doing good.
this has been like the hottest stretch, like when you factor in the heat index for us here since late last August. But our studio air is broken in the sense that it is about 47 degrees in there. So you go from outside, where heat index of about 105, and you go into the studio and you instantly freeze.
You know, they used to have like the stereotypical cold studio, right? It's like because the
The
lights
lights.
produce so much heat, right? Well,
Yep.
dude, for like the last 5 to 7 years, I've been working someplace where they have more LEDs than halogens, and they don't have to keep it so cold anymore. It's nice.
So that's what we were told. Is they were like, oh yeah, like we got these lights that don't give off heat anymore. We're like, all right, so why is it 48 degrees in the studio?
They must have like
But
just designed the studio to be constantly cold, no matter
I
what.
guess. But I mean, you like it some days, but man, when I work mornings, and you're already kind of like you're struggling to wake up, and you get in there, and it is just cold. I got this little space heater under the desk for those days. It's rough. I'm kind of a wuss when it comes to cold.
Well, it's a good thing you live in a state where it is warm 8 months out of the year, right?
Yeah, pretty much. We are considered a humid subtropical climate that is characterized by hot summers, relatively mild winters, sometimes wet. I just went to a garden club a couple weeks ago and did a Alabama seasons, so it's fun diving
Oh,
into all that. But
garden club. That sounds
yeah,
nice.
it's called Aldridge Gardens. It's right around the corner. Beautiful place. People do a lot of like engagement photos and stuff there. I'm sure there's stuff like that in around Kansas City. Very rustic, but I got some good tips on how to keep my plants alive because even though I understand the weather, I can't keep anything alive. So that was helpful. Good trade off.
I think my neighbors have started to look at my watering habits for when I think it's actually going to rain. Because I go out there, just I like water it on most days. But if I don't water it one day, I think people are
Like,
like,
wait a
"Oh,
minute,
oh,
what's he up to?
oh, it's actually going to rain this time, maybe." And like I put fertilizer out before I came to work today. I was like, "This is me telling everyone that can watch me out their window. It's going to rain tonight."
That's
I'm
awesome.
that confident.
I'll do the same thing for fertilizer, and it really is. It's kind of nice. The only part that burns you is when you do it, and other people are like, okay, he's onto something, and then like that storm misses your house. You're like, oh, come on.
Even I didn't know. Even I didn't know what was going on. For those of you that may be just joining us for the first
Oh yeah.
time, maybe those of you that are uh, new fans from the video that we did with David Paul about hurricane forecasting. My name's Wes. I am a meteorologist in Kansas City. You already know Evan because this is on Evan's channel. But Evan and I went to college together,
Hail
and
State.
now we do a podcast together.
Yeah, we do. Good old Mississippi State.
Hail State. I for the football season and yeah, for football season, I took down my Mississippi State flag that was flying in front of my doorstep. I was like, we got like 2 or 3 games into the season, and I'm like, I can't do this. Like, I
Can't do it.
can't. I can't proudly represent my school. In the wintertime, I put it up for a little bit. And baseball was good, but there's something weird about putting up your flag because you just got a brand new baseball coach that seems like no one will understand why your flag is up
No.
around here.
Our sports guys do, which is cool here because it's like, um, you know, as soon as our sports guy walked in, we hired, who's legendary. His resume's insane, so hopefully we go. But he was like, "You wearing your state stuff?" And you said, "Dang right, I have my socks on." Subtle, subtle. So, but yeah, we're state grads. Thanks for tuning in. Those who've been watching, we certainly appreciate it. Me and Wes, we love weather. It's why we do what we do, and we love to talk about it. We don't have time to talk about cool stuff and what we think is fun on TV. So it's kind of a way for us to chat about that. You can chime in whatever you think's interesting or what you're curious about, and we'll talk about it. We got some cool guests lined up too. former professor of ours, Grady Dixon. He's at Fort Hayes, right, Wes?
Fort Hays State University in Hays, Kansas. He went to Mississippi State, then got his master's. We got his master's at Mississippi State, then got his. Pardon me, I'm going backwards. Degree at Georgia, master's at Mississippi State, taught at Mississippi State, and is now the department head at Fort Hays State University in Hays, Kansas. For those of you that don't know where Hays, Kansas is, it is in the middle of Kansas. That's
I
it,
didn't.
just literally in the middle of Kansas.
I did not know that until I saw his return email to us. I was like, I gotta look up where this is, and sure enough,
It is in the middle of nowhere. Good for looking at tornadoes and storms off in the distance when they have them. But he was the one, first off, and my wife didn't want me to share this, but I think it's kind of funny. He gave he gave me a C in his class because I went to his office so often, like trying to get help. He's like, if you just
wait,
get
synoptic.
yes, and Synoptic is like, if you just get this score on your next test and you keep coming to my office, I'll give you a C. I was like,
Yeah,
sweet,
Grady was the best.
sweet, thank you.
He was because he just gave it to you straight. Like if he was annoyed with our class, like he told us, and it was fair enough. Like we could be just really annoying, and just you learn so much from some of these guys, and hopefully we can bring that to you. Um, Over the, I think he's back in town on like July 8th or something, so we'll have him. But God, I took him, Wes. We'll have to bring this up. I wonder if he remembers, but I was trying so hard to learn to write about the forecast discussion. So for those of you who don't know, so like we do broadcast. This business is so layered. You have the SPC in Norman, Oklahoma. They're in charge of issuing the watches, the SPC outlooks. Then you've got your local forecasting offices. So Wes has his in Springfield,
Kansas City.
Kansas City, and mine's Birmingham, BMX. Well, they put out a forecast discussion. It's a very scientific, very knowledge based conversation that the general public, you read it, you'd be like, okay, what's going on here? Well, I was determined to write like the National Weather Service. So I wrote Grady multiple, and he finally just said, this isn't your thing. And I was like, you're right. I'm a terrible writer anyway. And here I am trying to explain the levels of the atmosphere, what's happening at 500 millibars, and why that's going to impact a local viewing area. And I couldn't do it. It was a big miss, swing and miss. What I was decent at is communicating. It's just talking. So I ended up in the right place. But I'll never forget. I kept sending it to him. They weren't assignments. They were just things that I was trying to, improve on. And it just, he was like, it's not good. It's not
Right.
good.
And like in hindsight, now looking at NWS, um, AFDs, AFDs. Now it's just like I just use them to like see if I'm missing anything.
Yeah.
It's very general. It's like trough in the west is causing blah blah blah. Like just super duper, very very technical language that like is good to look at for like the overall synoptic pattern. And
Yeah.
synoptic is like large scale, and just to make sure like you're not missing anything, or like to see how your thought process is compared to another meteorologist. Sometimes you agree, sometimes you disagree, and that's just kind of how it is. But they use a lot of like very technical terms and like um, shorthand, like the word progged. The word progged does not exist outside of
No.
weather.
If you put in half the words that are in that discussion into like Google or a document, it'll have that little squiggly line. Everything else will take you to the National Weather Service, um, and their appendix or their full dictionary. It's quite funny. Um, but you know what you didn't need this week, Wes? And I said this a couple of times on the air, and I don't know that the bosses love this, but it's transparent. You don't need me. It's freaking hot. It's hot.
I actually love telling my producer producer is like, hey, just give me like 230. Like, I'm just really not important. Like, I don't even, like, that's like, I know my place. I know my place. So when I need my time, I need it. And when I don't, I don't.
Yeah. Although this week, they were kind of pushing the narrative, and I was having a hard time because they're trying to find what the weather story is, and there's always something happening in weather. But this week, heat levels were par for the course. Even the heat index, which sucked at
Mm-hmm.
times, was not by any stretch of the imagination, the worst that we have. So um, it was kind of interesting at times filling the whole time. But yes, telling your
You do like
producer.
explainers. How did you feel it? Did you say more cities than usual on your
Um,
currents?
I no, that's a good question. I actually did some time lapses. So we've got WM Vision. It's a Skycam network that is across the country, and they've got really really high def cameras. And so there was a tremendous amount of lightning with some storms. So I explained heat lightning. I talked about how you can be up to 100 miles away from a storm and you can see the flashes, but sound, it doesn't travel that far. Sound waves don't. Light will. So you'll see it, but you won't hear it. And that's where the myth of heat lightning came from, as people would associate the hot summer months and seeing these storms that at the time were 40, 50, 60 plus miles away. You get these flashes, you don't hear anything, so you assume that the heat has generated it. And
Yeah.
it's a very logical thinking. But we know now
In
that
fact, Evan, lightning is heat.
it is. Lightning is very hot. It's very hot. In fact, I wouldn't recommend it. Um,
So heat lightning is actually not that wrong, but it is.
are you trying to be? You
I
trying to
had
be that guy?
I had a buddy of mine bring that up, and I was like, you know what? Like, yes,
If you put
yes.
it in that context. However, most of the time, what it's brought up is like, how come y'all aren't talking about this heat lightning? Because the general thought is, well, this is being generated because it's hot, and it correlates with the time of year where we're really hot. So you
Mm-hmm.
kind of get it.
Yeah, yeah. No, that's one of my favorite explainers. It's just a storm that is more than 10 miles away. That's all it is.
I was
And the
trying to
wave,
grab this upper air map,
the waves
but
fizzle out. So we are gonna have going back to that Professor Dixon thing. He's gonna come on in a couple of weeks, and he's the mastermind of Dixie Alley or Southeastern Alley. I don't know what we're calling nowadays, but he is the one that will shed some truth, some light on um, what Evan and I think, will describe it to the fact that it's a myth that Tornado Alley is shifting east. So we're looking forward to that a lot.
yeah, and so I've done some crunching of numbers, and really, I'll just throw
Crunch them,
one thing up,
crunch
just
them
as like a
good.
tease. And I was gonna send this in the email, but I was like, you know what? Let's wait until we get to talk to Grady because he's done a lot of research that is far, far and away deeper than anything you know
Oh yeah.
we could do. So um, it's very fascinating. Again, my skills with Excel and PowerPoint are just incredibly bad, but I've got it right here.
All right, let's see it. All right, the drum
No, this is where you're supposed to like
roll.
entertain
Well, I
for
was
me.
going to say part of the reason why we believe that it's not shifting east is because of the same reason that we don't really take the hurricane records before satellites as seriously. So usually, like the hurricane records start around the 1980s because we weren't seeing like the entirety of the ocean basins to really see all the storms. Like you didn't really know. Like for instance, there was a tropical storm. I assume it was like Andrea. I assume that was
Andrea, or yeah,
Andrea. I didn't look at the pronunciation. I had Andrea. Um, like probably wouldn't have seen that unless a ship went through it. Then we wouldn't have known that that storm was there. And there's very similar characteristics to the tornadoes across rural parts of the United States, and the fact that the way that we detect it and we share the information has changed in the last 30 years or so. And I think that that is an underappreciated aspect to all of this.
All right, so here is kind of just a little bit of what I have, and this is, there's varying data. I think we talked about this on a previous episode that, if you go to your local forecast office, you're going to have numbers that each forecast office goes in and they investigate tornadoes. So what this is here, the green is a mark of total tornadoes from 1950 to 2023. All right, it's over 45,000.
Hmm.
The blue is going to denote Tornado Alley, the classic Tornado Alley, which I have to tell you, Wes, this, depending on what you look at, the numbers change because not some of these states, there's several different definitions, but I picked Texas, Kansas, Oklahoma, Nebraska, and I put Iowa, Missouri, and South Dakota in there. You could make the argument some of those are out.
Like
Some of those
Missouri.
are very, you could make the yes. And I could take Missouri out of this and we can reskew all the numbers. It's very easy because I have everything already plugged in. But either way you look at it, Missouri's not a huge swinger. What is very interesting is the overall occurrence. If you look at Dixie Alley, which I took Louisiana, Arkansas, Tennessee, Mississippi, Alabama, Georgia. Okay, there's no Florida in there, there's no South Carolina. Those are not part of it. But look at the numbers from 2000 to 2023. Okay, there's over 8,000 tornadoes compared to the combined number for the previous 50 years. So from 1950 to 1999, there was just under 8,000 total tornado occurrences on record. You have in a 23-year period that exact amount of 8,000 plus. So it's a very interesting thing. I'll be excited to hear what he has to say with respect to the shift, because clearly you can see there's something's happening over the southeast. So is it as simple as we're seeing more? Are they being investigated? Is it the intensity that's being? Are we now investigating wind events, finding out they're EF zeros, and those are getting tacked on there? There's just a lot of questions.
That's good. That's good. And yeah, I think whenever we talk with Grady, you'll see that there's so many more reports of very weak tornadoes in the last 40 years than the previous, and like it's super duper obvious.
That's where I want to get his opinion on this, because we've lived in Mississippi. I've lived now in Alabama. So between the two, I'm from Georgia, Mississippi, Alabama. For 32 years, I've lived in this part of the country. To me, the weather has not gotten that much more significant as far as tornadoes. With that said, we've had some anomalous years. 2011, right there. Even 2021 and 2023 were both high years for us. But we've also had several events that have conjured up EF zeros, very low end tornadoes that we would not have seen if it were not for improvements in radar. Because keep in mind, for a tornado to be documented, you got to have a team that goes out there, you got to have damage, you got to have a storm report in order for that to be counted. When these things touch down in the middle of a forest that's 300 acres, people may have no clue it's there. So I think now they do. But a little tease, that'll be fun to talk about with
Yeah,
Grady, because he's a lot smarter than us.
for real. Can't wait. We have a sweet sunset in progress right now.
What?
I
Throw
may
some
I
of that
may
up.
at times be dipping in and out. For those of you that are not privy to what's been going, that's a fat sunset in progress. There was like a huge line of thunderstorms that blew through Kansas City, and there's more thunderstorms getting closer to us, and so I kind of have to like keep my head on a swivel here at times to make sure I'm not missing anything, and we're like gathering storm reports. The part of the job of the broadcast meteorologist is like forecast, give the information, and then help um, get the storm reports and the and all that stuff, and help send like your news crews to where they need to go, and everything. So I'm in the process of fielding storm reports, and then making sure that there is not any more bad weather coming. And there is, but it's like an hour away, so I think we're good.
All right, so we got a little bit of time. We can steal West. Okay, so this is
Oh
kind of
yeah,
what we wanted to talk about in a nutshell. We kind of been all over the place. That's what we do. We just like to talk and talk weather. So um, we obviously the heat's been a big story. We had no records here in Alabama. There was nothing too crazy out of the ordinary. It doesn't mean it wasn't impactful. I'm not trying to say that, but we have heat index factors that approach 108, 110. That's possible from mid June through late August here. What about you, Wes? And your DMA, did you have anything that was close to records?
not really. Um, it was just like plainly hot. I mean, the first day of summer was last Friday, right? And it's been 90 degrees every single day.
Yep.
Since then, it's been like 90 to 93 degrees every single day. So, like, that's hot, but that's not a record. Like, you need to get like 97 or greater to really get a record. And it's felt like about 100 degrees for the heat index. But no, and that's what's really interesting about this. Like, the Maryland Science Center, which, by the way, is probably like in a very urban area.
Yes,
Um,
I'm thinking so because that's I'm trying to filter through some of these are outliers, and when you look and you see like ThreadX, I don't know how reliable that is of a sensor. I'm not denouncing it. We have sensors in our DMA that are wonky and read wrong all the time.
oh yeah,
But the consensus here is you see a bunch of 98, 99s. I fully believe everything in 98 plus up to about you know the 105 that might be exaggerated because it's in an urban area. I'm looking at the on the other screen. Um,
and then the other side of that argument is like, yes, 105 if it's on concrete in an urban area, like yes, but like also, I mean, people are still experiencing 105 degrees, so it's really tough to like discount those numbers completely because our job is to forecast the weather that people are going to experience, and it may have been 105 degrees in a very small area, but people were walking around there experiencing 105 degrees in downtown Baltimore.
Yeah, and for those of you who don't know, Wes did a really good explainer on urban heating and how it can influence thunderstorms. It is always a good deal hotter around a city. What would you say, Wes? 2 to 4 degrees, sometimes up as
It's
6.
Yeah, it's supposed to be like 2 to 10 or something like that, but it really depends on the wind speed, how much, well, how dry the land is in the rural areas versus the urban areas. So yeah, that's why it's like 2 to 10. If it's moist, smaller. If it's dry, there's a larger difference. If the wind is calm, it's a larger difference. If it's a strong wind, there's a smaller difference because there's more ventilation of the warmth coming off the city.
So just to give you an idea, Wes, none of these top ones right here on this list are part of the National Weather Service's sensors. So
Okay.
this one has the max temperature on the 24th, where this is showing at 98, and a lot of the other areas right at 98. So some of these sensors could be a bit wonky.
Okay. All right.
With that in mind, it was hot. We were approaching records across the Ohio Valley. And I definitely think that was the weather story. So then we talk about the dome of high pressure.
The dome.
What is the dome?
The dome.
That's where I'm
Uh,
handing off to you.
and I think of like a dome. Like I understand the idea behind describing it as a dome because it's like holding things in, holding the heat in, not allowing for stuff to move. But a dome is an area of high pressure, and an area of high pressure is the air pressing down. And the further away you get from the center, the lower the pressure you have. And so when I think of a dome, I think of like curved, like like this, right? But
Okay, now you
really,
might be onto something. Stop
right?
getting
So
wise, man.
this is your what the dome is perceived to be, but really the dome is actually like this, because it's pressing down the in the center, and then the pressure is getting lower as you work your way out. And so the particular like super nitpicky part of me is like it's not really a dome; it's just like a circular area because pressure areas are circular. But like I don't know that it's kind of it's that's what has become common like nomenclature to call it a heat dome, and plenty of meteorologists call it that, and so it's just like whatever. If that helps you describe it, that's fine. But I know Evan, you have more to say on this.
Well, I think so. Something I remember being told is a couple terms that like we were never supposed to bring out. It was fog burning off. I'll never forget
Yep.
that. I think that may have been Dr. Mercer. And then there was dome of high pressure, and that may have been Greg Nordstrom. I
I don't
can't
know who it
quote.
was, but yes.
It was kind of ingrained, and the idea is because it contradicts itself, sort of like what you were saying, Wes. Is yes, it is a big ridge of high pressure, but it's not a dome that's trapping in heat, that is keeping heat from escaping, and that's kind of you go to a football game, into a football stadium or a hockey arena or a basketball arena. Okay, there's a ceiling everywhere. It's all locked in. So the idea of a dome, to me, gives the idea that hey, there is this big area of heat and there's nowhere for it to go. It's all locked in. It's this dome of heat and high pressure, and it's not a great explanation because it really is sinking air. So when we talk about when what we had this week, we also had very, very low rain coverage. And when you think about convection, I say this all the time. We have convective thunderstorms every day. What is convection? That's a fancy term for rising motion. Sun
Mm-hmm.
comes out, heats the surface, whatever water's there, air parcels rise, condense, boom, you got clouds. Keep
Mm-hmm.
condensing, boom, cumulonimbus clouds. Keep going, you got strong thunderstorms. So that's the process on a day in and day out basis. What we had this past week that really limited our rain coverage and accelerated those afternoon highs reaching the upper 90s is the air aloft was working against convection. So if air's not rising, it's got to be sinking. And under a ridge of high pressure, you have a sinking air mass where the overall stability of the profile is pretty good, meaning you don't have a huge temperature difference in the upper levels to the surface. There's always going to be a difference because you have surface heating, but it's less of a contrast. And so that sinking air with that high pressure aloft, remember, high pressure, it means we're pushing air down at the surface. Low pressure, there's less at the surface, which means air is going away from the surface versus high pressure, it's coming down. So the idea of a dome doesn't really work in that aspect, if any of that makes sense.
Yeah.
But we had sinking air aloft, and that is why not only was it hot, the typical thing that would cool us down, at least from a local standpoint of pop-up thunderstorms, they were all subdued. They didn't form because of that sinking air.
Subsidence. Yeah. And like think of it as the air pushing the cloud down. It can't grow up. Can't
I
grow up
think
to be a big, strong cumulonimbus.
they can't. They were stunted. Sorry, man. Sorry, little cumulus cloud. I did a little video the other day. I did these little walk and talk weathers, just to casually talk to people. Like, hey, here's what we're looking at today. And I panned around and I said, see all these cumulus clouds? We've had rising air, and we have had obviously the condensing process to form clouds.
Mm-hmm.
However, because there's that stable, we call it a cap, there's a point in the atmosphere where the cloud just it doesn't grow vertically anymore because there's not that big unstable factor. Now every now and then it'll punch through that cap. You'll get strong enough
Right.
rising air and it's like, I don't care, I'm going straight to the moon with this one. And you'll get these towering convective storms. But I showed a video, I said, look at all these common fair weather cumulus clouds. They don't allow for really the development, the evolution of thunderstorms as we would expect them to be normally in an unstable atmosphere. So that ridge, that dome, for what it's been called of high pressure, it doesn't, that analogy, as you can see, doesn't really work.
The
So
cumulus humulus or something like that. It was like a cumulus humulus and cumulus mediocris.
cumulus congestus,
Go
cumulus,
congestus are the ones that are developing. Yes,
they're just everywhere.
vertically developing.
So
Well, let's see. Let's see if we have any of these ridges showing up. Let me pull up a little weather map here and see what we got going on. By the way, Evan, in our last episode, when we were talking with David, I was telling him about the Euro ensembles. Okay, that is now available on Weatherbell. If you're in the Weatherbell, That's
Oh,
now
awesome.
publicly available. So I would highly encourage you to do that because it's pretty good.
For anybody out
Even
there, by the way, a little sidebar: knowledge of weather. You don't have to have this as a career, but weather impacts everybody everywhere at some point. It doesn't matter your career, it doesn't matter your lifestyle. At some point, it impacts you. I think the more you know about it, you don't have to be an expert. Me and Wes learn stuff. I learn stuff. I feel like weekly. I've never closed off to learning, but you can always learn about stuff, and I think it can benefit everybody. So have fun looking around. All right,
a
continue.
missed forecast is an opportunity to learn.
Bingo.
So that's it. Okay, so over here you can kind of see that's like the ridge. That's the remaining of the dome, if you will, right? And then it kind of flattens out here a little bit. But then next week we start to get maybe another little ridge forming. I don't know if you want to call this a dome again here, but
Don't.
this is me. Evan's over here. This is me over here getting in back on the ridge.
Oh, you're in the Axis, man. Oh yeah, you're toast.
Yeah, we're not even like if we were here, I'd be like, okay, cool, we got some storms coming. You all, I don't know. Do you all get? Are you gonna get any isolated
Sometimes we get
thunderstorms next week?
what's called ridge riders, where
Oh
they
yeah,
will actually form on a boundary and they will ride that ridge. Because we're almost never cut off from moisture being close to the Gulf. So if those do form upstream, they usually can make it to us and they'll follow that sort of upper air pattern. So that would be, probably stuff moving from northwest to southeast.
okay. Well,
If they
let's just look at the Fourth of July forecast for everybody real quick. See what we got here. You look fine.
All right, y'all heard it here.
You look fine.
West Perry from Kansas giving you your Kansas City giving you your Alabama 4th of July forecast.
And it might rain here. Might rain here. I got to work on Friday night, 4th of July, so it can rain.
Me too, man.
Won't make me feel so bad missing it.
Yeah, the rain is a big question. A lot of people headed to lakes, fireworks shows, all that stuff.
Yeah. Well, they make the lakes. There's a really big one called Lake of the Ozarks here in Missouri, and that one may get some rain. It looks like Saturday. There's a front coming through. Probably good on Sunday. But then is this front actually going to make it into Alabama?
We don't get
No.
fronts. No, it's a ghost front.
Yeah.
It doesn't exist.
It does kind of fizzle out there. I can see that. We lose those greens, and it turns to grays.
They try this time of year. And our best bet of getting a front is with a little cool air wedge. That cooler air off the North Carolina coastline that's north of
Yeah.
the Gulf Stream. If you get a high there, it'll send it down the Appalachians and it'll be cooler.
Yeah.
But
Some CAD.
a little CAD, cool air damming.
Let's see what's supposed to be now the world's most accurate ensemble forecast has to say. 4th of July, pop-up showers for me, pretty much nothing for you.
Yeah.
And then a bunch of fizzled out nothing. Will this give me temperatures? Oh, yeah, okay. Will it give me numbers, though? Am I too zoomed out? I'm too zoomed out. Let me see. It's exciting stuff.
This is.
Usually
AI
you pay for this.
is being introduced in every, I think, facet of work that doesn't involve like digging into the ground and landscaping and architecture and all that stuff. And you really do have to kind of embrace it and understand. David put it well. He's like, you have to understand it. You can't just use it, on a whim and put it out there because there are biases to everything and you have to learn how kind of it behaves, but it's becoming part of everything. So learning about it, it's important.
I will say the AI weather model today. Oh, Evan, there's a sweet rainbow outside. Oh man,
I wish we could turn your webcam. Okay, David.
Let me see if I can get it. Hold up.
You gonna try it?
Hold up. Let me see if I can do it. Because I was seeing a shower going on, and I was like, "Why is it raining?"
All right, 1 part rain, 1 part sun. Full on rain barrel.
Can you see any of that?
No, it's not doing it justice at all. I see a great reflection of your station ceiling lights.
Dang it. It's a pretty good rainbow. And I have enough weather pictures for today, so I'm not gonna.
I love good weather. So
I have enough weather pictures for today, so I'm not going to go outside and take one. There's no time. There's no time for it. Okay, but what I was saying is that the AI weather model actually handily out forecasted our short term like models that are actually made to predict storms, like handily.
Like the
It was
her.
great. Oh, it's so much better than the her and the NAM, which is awesome because I based my forecast on it yesterday and I was a little shaky. And yeah, worked out well for me, which doesn't always happen. I'm wrong. I'm wrong. I'm wrong plenty of times. But here is the very accurate weather model. It says it's going to be like 90 degrees. So Evan, what I do with this is it only gives me like 6 hour temperatures. So it's like, all right, at 1 o'clock it says 87. At 7 o'clock it says 87. So it's like probably going to be like 90 degrees that day. And then you in Alabama at 1 it says 92. At 7 it says 89. So it's like probably going to be like 94 on the 4th
That
of
actually
July.
sounds. I mean, that sounds spot on. We almost every day we have a chance to get to 90 if we don't have rain. If we have storms, it's 88. If we stay dry with a good ridge, 94.
This looks like 95 on Saturday and then again Sunday. Feels like 100 with the heat index.
Yep, you just explained Alabama weather. So I'm going to go on sabbatical here,
All right. Sounds
and
like fun.
we're just gonna let it be on cruise control for the for the rest of the summer. I hate monotonous summertime forecasting, but it does give it a good chance to explain different types of weather. So I always appreciate that. Um, with that,
This is why people in the South wear swim trunks when they walk around and they're not going to the pool
there's nothing wrong with that.
because it just is wet internally.
All right, let's talk about. I just want to show this really quick as a simple explainer. So when
Yeah,
Wes and I have talked about atmospheric heights. Um,
I
when we
do
look at
love
these
me some
height maps,
atmospheric nights.
do you what?
Nothing. Go on.
Okay, stop your nonsense. All right, so we show these height maps, and Wes just showed it. When we talk about the upper air profile, 500 millibar maps are between 18 and 20 plus thousand. It ranges because we're looking at a pressure level. It's 500 millibars. Okay, so when we show that the atmosphere is higher or we have higher heights, it's because warm air takes up more space. But you can still have sinking air as part of it, and here's essentially why is where that high sets up. So you look at, I mentioned high pressure, it pushes down. Okay, so from this point in the atmosphere, which is the middle of the atmosphere, about 500 millibars. All things said, it's not exactly the middle, but when we look at forecasting, right, it's kind of in between the lower atmosphere where we're predicting all the weather and then where the jet stream and everything else happens aloft. So you have this air that's above, that's extended above, but this high pressure is exerting force towards the surface. And
Mm-hmm.
it's also propelling and steering, your currents north, south, east, west. Have you ever looked at a map where there's a high? It's moving clockwise. Okay. So that air is being pushed towards an area of lower pressure. This is how we get those circulations in the atmosphere that drive our weather. West, right now we have a upper high that's north of us, which means our winds are coming out of the east. So our thunderstorms right now are moving backwards from normal because of this process. We're seeing our steering winds bring storms from Georgia into Alabama. 89, 90, 95% of the year, storms come from west and move east, some form of to the west. But because of this circulation right here, it's backwards. So we have high pressure here, lower pressure to the west, and that is forcing storms to move in that direction, just like what you're seeing here. And because of that sinking air as well, it's killing the ability for us to have that convection. So you basically have an atmospheric profile that looks like this. And the word you used earlier, Wes, which is subsidence, is exactly what's occurring. You have a higher atmospheric column because the air's warm, but the air's sinking. It's not this huge ridge or this bubble, as it's sometimes said, of just warm rising air. It's not that simple, but it is one of the things that helps us understand how the atmosphere works, and one of those things that can really have a big influence certain times of the year on what your weather does. When you have a big ridge like this set up, when you see this, you can often expect that you're going to be in a period where you're warmer. There can still be thunderstorms because a lot of times that daytime heat it can overcome the sinking air. But when you see a big ridge over your area, warmer highs, lower convective rain chances, at least down here, and that's really what we saw this week across Mid Atlantic, parts of New England, Ohio Valley. So welcome to summer.
Spoken like a guy who got a better grade in synoptic than I did.
I was trying to remember if I got an A or B. I think I got a B. I think I had like an 88. And Grady was not one to just like reward you. I did appreciate he made you work for everything you had. But I think I got several A's in my meteorology core courses.
Hey,
Um,
proud of
calculus,
you.
physics was not good. Um,
Um, Speaking of areas of low pressure, I was trying to figure out how long Tropical Storm Andrea lasted.
I don't even know. I didn't really give it a whole lot of attention because I immediately texted Wes because as he said, there are before you go back to the satellite era, it didn't even really become very pronounced until well after we had the space race and everything. We never would have known of these storms. So if this year, Wes, if this season we finish one or two above average and you throw Andrea in there, did we have an above average season or did we name something that we otherwise wouldn't have seen and now we've skewed this season as above average? It's all very
Yeah.
relative and it's a slippery to me it's a bit confusing.
Well, what I'm going to do is go to, which is actually a very reliable source for this one thing in particular, and that is the Wikipedia page for the hurricane season.
There are
I
some
don't
people
know
keep
who
that up.
maintains it.
Someone.
I don't know if it's a bunch of people, but it is so good. It's really weird how good it is. Um, it's very detailed. Okay, Andrea. Oh, it doesn't have when it died. It June 25th. Okay, so June 25th at 3 UTC. So that would be really would have been Tuesday. Tuesday evening, it became a storm.
And it fizzled out. I mean, the following afternoon.
Oh, I'm sorry. June 24th, the morning of June 24th, it fizzled out. And then, yeah, the, no, dude, the same day.
It was a very short time period. Again, I didn't really look into it, but this is the type of stuff that I don't understand why name it. So something else we'll learn about in the tropics is sometimes you'll see intensification with a low overnight because when you lose daytime heating, the cloud bases and the sea surface temperature will be a little bit closer in temperature, and you'll sometimes see that develop. That's something I learned from David. And you saw that intensification overnight in the North Atlantic, and then it's gone. So I didn't understand that at all. But
It looks like it went from at 11 a.m. Atlantic Standard Time. It was called Tropical Storm Andrea. At 11 p.m. Atlantic Standard Time, it became a remnant low. Dude, that's the type of stuff that really screws my forecast.
yep. And
That
I
is
texted
so funny.
for those of you out
That
there
is
who are still watching. I texted Wes and David same time. Said, "How about this?" And the reaction was both. And this is the thing too, where I see an impactful storm and the outlook can say one thing, and this was my argument beforehand: is the outlook really helping? Because if we have a bunch of storms that are like that, well, if you looked at the outlook and you saw named storms, 16 to 18, it's a high number. If you saw hurricanes and it ends up being up there, you look back and you go, well, wait a minute, they were out in the middle of nowhere. One of them wasn't even named for more than for a full day. So that's the type of stuff that can become convoluted a little.
start adding qualifiers to our forecast, like storms that are alive for more than 24 hours.
Oh my gosh, I don't. But Andrea, whatever.
Oh, I didn't. I'll have to look up the pronunciation guide to that one.
I
I
don't
guess we
know.
didn't have to. Didn't even have to look up that one because it wasn't alive long enough to talk about it on TV.
Yeah. Okay, a couple cool things I want to show here and share before we got to go. I know Wes has got some weather moving in, so if you have to go at any point, you let me know. But
This
on a
rainbow
pre,
is persisting. I'm
on a,
hoping that I can get this rainbow
you
whenever we're
pretend
done.
rainbow. Okay. Wes shared some stuff about the urban heat island several episodes ago.
Oh yeah. Okay. Yeah.
So this was this evening, and this cell is moving basically due west, and then it hooks back towards Atlanta. Do you see at the very kind of tail
Yeah.
end? My radar scope would not grab any longer than this, but it was very interesting to see it turn and basically back build towards downtown um, throughout the evolution of this storm. So west, basically, the idea was that the temperature gradient that is developed between some. This is a different storm between the suburbs, which can be, well, we'll say Kennesaw was 91 and Atlanta was 96.
Okay.
Okay, I think it was more like 88 and 94, something like that. But that these storms will intensify, and it did. It got a hail core, right about the time it started to go around right there. It right in the middle of it. Let me see if I can pause it.
It zings around a little bit there.
Yep. Okay, so right here, it got a little hail core. That's right in here. All right. And it just intensified, and the whole thing initially, the warning is it's moving off to the west, and then it just hooks back around towards central Atlanta. I just thought that was cool, and it made me think of Wes, and I thought, look at that.
Uh, Loop it again. Let's see here. Like it seems as if the person drawing up the warning kind of counted on that. You see how it kind of
Yep,
they
you're right.
made the box bend a little bit, but they didn't think it was going to bend quite so sharply to the east. But that's cool that they're very aware of the urban influence on the storm. They're just going to hook it back toward the heat. and it's
All right.
and it's not so much that like the storm is moving. There could be a little bit of movement of like the storm, like it's not that the storm is blowing over the city, it's that the storm is intensifying and then generating over the hotter parts of the city.
And that's exactly, if you look right where the A is. I mean, you're right there. Wes, you worked in Atlanta for a couple years. You're getting right into the thick of everything. You're near Midtown. You're just north of the airport. I mean,
Yeah.
there's a lot of infrastructure there. And so I was watching this, and I pulled it up on radar during my weathercast, because the way that the weather's worked here is these storms that form in Georgia, they're drifting in Alabama by nightfall. And I saw that and I thought, oh man, that's cool. And I'm watching the different sky cams in Atlanta from the airport, and you just see this thing. It looks like it's on its way out, and then it evolves in like back builds. So
That's fun.
weather nerdy stuff. All right,
That's
this was
fun.
last night. I just wanted to show this to Wes, because so for those of you who live in Bibb County who are watching this, which might be nobody,
So
this is our
Bib,
DNA. This is a very rural county. Okay, this popped up a little bit before 9 o'clock, and the base of it just didn't move for almost an entire hour. So it looks like a smokestack. The top of the storm is being blown, and within the cell itself, right beneath, basically right here, 2.6 inches of rain and just over 30 minutes. West Blockton, which is the town nearest to the north, Centerville's just to the south, Brent is right here. Trace amounts of rain. Trace to 2.6 inches. How do you explain that, Wes?
I
Hey,
don't know.
everybody but one area of 5 square miles is going to get nothing. Then you're in that little square, you're going to get 2.5 inches.
Okay, so let's think about this. The storm is generating because of heat, and the wind is like ventilating the storm. So it's at least cooling it off. But is there, I, I guess, is there just like some sort of perfect spot of like the heat is still coming up and there's no wind to push the storm around, to steer it around?
So sun went down at 8:02. This didn't form until after the sun went down, and it reminded me of a smokestack. If you ever look and see like or if you see like a power plant and you see the steam, the stack doesn't move, but the steam goes up and is carried by the winds. It made me think you have this very well structured storm that was not moving at the base, but as it went up the atmospheric column was carried away by the flow in the mid levels, which, as you saw, Wes, that is northeast to southwest,
Yeah.
completely backwards. But this is what caused me to hop on YouTube last night and go live, because this had a warning on it for a little while, because as it pulsed up, it briefly had hail and some strong winds. Now, this was an incredibly rural part of Alabama. Bibb County is very rural. But this is all trees and fields. There's no infrastructure over here, unlike the
Yeah.
Atlanta thing. So this just, it found a hole in that very stable atmosphere we just talked about, and it punched through. It punched through because it formed all by itself. There was no boundary there, nothing.
That's fascinating.
Yeah, it was fun.
Learn something new every day.
Yeah.
Trying to.
So, and then if you don't have anything else, I have one other thing.
I don't. Go ahead. Go ahead.
Did y'all hear about the fireball that was seen over Georgia and the Carolinas?
Oh, yes, I did actually.
Okay. This was a meteor that came in. Most of the time, meteors come in, for the record, meteors are hitting our atmosphere constantly. A lot of them burn up in the upper atmosphere. We got 5 layers to our atmosphere, and the top couple have just enough gas density to burn up meteors. It's very important. Most of the time, the meteors are too small. We don't see them burning up during the day. But at 11:18,
We got the range rings on here.
okay, this is important. You can only see the meteor show up on radar for one scan, Wes. One scan.
Oh,
This is 15,000 feet up, because it's about 150 miles from the Birmingham radar beam. Again, the only radar I think you could see it. It's right there.
oh,
Not interesting at all. It looks like nothing. I had to go back and forth on radar, and I'm talking to James. He's in the office next to me, and he goes, "Stop it at 11:18." I'm like, "Okay, 11:08, like Atlanta time?" He goes, "No, no, stop it at 11:18 Central Time. Use the Birmingham radar." So I did. There is nothing on the radar at all at any point. You would not have seen this unless you knew exactly where to stop it. This was at about 15,000 feet, and it's capturing that clutter from the meteor coming through at that exact time, and that's what it looked like on radar.
that's pretty crazy. I do not think I've really ever heard of catching a meteor on radar. Did you look at it on like correlation coefficient or anything?
You know what? I did not, but I can. Let me
Oh,
look at that.
I have the technology.
But it just was so interesting to see that this, that could happen on radar. I've never seen a
Yeah.
meteor on radar. I don't know when I ever would have needed to look. Um, but
Now you're a meteorologist tracking meteors.
funny
Tracking
stuff.
meters is a meteorologist.
I went to a talk the other day, and one of the guys was like, "I love destruction and I love meteorites crashing. That's what you do, right?" And I was like, "Well, first off, I don't love destruction. Second, yes, meteors as they fall, we track them and everything, but it's not exactly what it sounds like all the time." So I'm gonna go now to
That's a
our
classic.
right.
As you're getting this set up, I I assume it's going to be like a ball of blue, like how we use this correlation coefficient product to look for debris from a tornado. And so it'll give us different colors based on like the shape of what the radar is picking up. And so I'd assume that like this fireball is a bunch of different, I guess, yeah, I assume it's a bunch of different shapes
Yeah, I would
going through the
assume navy
sky.
blue too. I'm actually a little surprised at the color that pops up here.
Oh, so it's not, I'm wrong. All right.
No, but you're right on the different colors, because so what correlation coefficient does, and this is what helps us in when we're doing severe weather, what it's going to do is it's going to take what is supposed to be in the atmosphere and show it as one color. And so we know, okay, that is supposed to be there. Then in a certain clear air scenario like this should not be there. And I believe this was the unincorporated town of Irondale. Yep, Irondale. So right here, it actually went through a house. Part of it went through a house. What was left of it? I mean, when a meteor comes through, it's burning up, it's breaking up, and it went through. But this is the exact same time. You see 1118 here, and this is correlation coefficient. There's reflectivity.
Yeah.
I don't think any other product's going to show that.
That's pretty crazy. So it landed like in Alabama.
No, so I don't know where it exactly landed. So this is in Georgia. This is so there's Atlanta West, get your bearings, and this is
Yep.
down
Atlanta.
south. So the trajectory of it was off to the east. That's why we didn't see it really in Alabama, unless you were in East Alabama. But a lot of people in Georgia saw it because of where it
Okay.
was moving, and it came in. I mean, humming in at this general trajectory, and so there was a lot of reports over in South Carolina. Basically, the only real looking into I did was, okay, was this picked up? And the reason we have to use the Birmingham radar, and I was talking to James about this because he's just a very, very smart meteorologist, human being, person in general,
Yeah.
is you can't see this from any other radar because, as we know, Wes, and for people out there who don't know, the radar beam, it gets higher with height because it's at a very, very slight tilt. And it increases by, what is it, 1,000 feet every 100 miles?
I actually never thought of that. I don't
10
know.
miles? Anyway, the radar beam gets higher. I'm terrible with math. I know this, but it's 150 miles away, so it's roughly 15,000 feet up. So at this point, the radar beam is hitting 15,000 feet high in the atmosphere, and it intersected this debris from the meteor as it came through. And you just see it for one scan. In fact, if I move this forward or back one scan, there's 1122. You can see, I guess, some of the remnant nonsense.
Mm-hmm.
And then if you move it forward, I mean, there's nothing there. But just
Wow.
I thought this was so cool.
Did you post that on social media?
No, I haven't posted it yet. I'm not. I've been looking into this like this evening, like as we were getting ready to talk. I was kind of looking into it, and I'm not an expert on this stuff. I felt that I could share what I knew here, but there's a lot of smarter people that have posted stuff on this that are probably more beneficial to learn this from. But knowing that the meteor came through, that it did register as a loud sonic boom to some folks. People thought that there was actually an earthquake. They reached out to USGS and was like, "Hey, what's going on here?" They're like, "No earthquake. It wasn't us. Call NASA." So,
Oh, that's funny.
but anyway,
And you can, because Huntsville is just right there.
yeah, they're right up the road. Some of the smartest people we got. And the next time you think, maybe NASA's not super important because space is space, who do you think tracks all the really dangerous, large meteors or rogue planets we got out there? We need them, folks. You guys ever seen Armageddon?
Yeah. I'm more afraid of that killing us than
Oh
any
yeah.
other weather
Can you imagine
phenomena.
a gigantic rock just flying through space? Can't see it, can't detect it. Oh, you got 15 or 18 days is how long you have in Armageddon. In short,
Oh,
NASA does a lot more than that, but they
yeah.
have constant surveillance of our solar system. They have tags on rogue meteors and all sorts of stuff, so they're very important. But
That's a fun job. They're the true meteorologist.
that's your
Meteor.
astronomy minutes right there.
Meteorologist. All
So
right, this meteorologist has got to run because I got some more meteors coming in.
I hope you guys learned something. It's kind of all over the place, but we'll do this again. We'll meet up with Grady Dixon, and if you want to talk about something, drop it below. We'd love to have you part of the show.
Yeah. Thanks
For
for
Wes,
watching.
I'm Evan. We're sort of wise guys, and we appreciate you watching.